Okay, for this next lesson, we're going to take a look at solving rational equations. So, the first thing we need to do to solve a rational equation is to multiply each side of the equation by the lowest common denominator. This is going to eliminate all the fractions that exist. Then I'm going to solve the equation by isolating the variable just like I usually would. And then the last step is I need to verify the solution to make sure that when I multiplied everything out, it actually works. So, for the first example that we have here, the first thing is I'm going to take a look at the denominators and I'm going to say, well, I have a 3, a 4, and a 6. And the lowest common denominator for that is going to be 12. So I'm going to multiply everything by 12 in order to divide it out. I'm going to state that I have 12 and 2x plus 1 over 3 plus 12 and x over 4 is equal to 12 and 5x minus 1 over 6. At this point, I'm going to divide out that 12 that I multiplied in by the denominator so that the fractions are going to disappear. So I'm going to say that 12 divided by 3 is going to be 4, and then leave the brackets, 2x plus 1. Plus 12 divided by 4 is going to be 3 and x, and then 12 divided by 6 is going to be 2 and 5x minus 1. And I'm going to multiply out to get rid of the brackets that I have. 8x plus 4 plus 3x is going to equal 10x minus 2. I'm going to move the x's all to the left-hand side, so I'm going to have 11x's when I combine these like terms, and I'm going to subtract 10x when I move that over. And on the right-hand side, I have negative 2, and I'm going to move that 4 to the other side, minus 4. And I just get x is equal to negative 6. Then I need to verify that this actually works. So what I'm going to do is I'm going to replace the 6 in where the x was. I'm going to say 2 times 6 plus 1 over 3 plus, negative 6. Negative 6 over 4 is equal to 5 times negative 6 minus 1 over 6. What this is going to give me is negative 12 plus 1 over 3 plus negative 6 over 4 can get reduced down to negative 3 over 4 is equal to negative 30 minus 1 over 6. Or negative 11 over 3 plus negative 3 over 4 is equal to negative 31 over 6. Well, I'm going to need to put the over 3 and over 4 over a common denominator, and the common denominator in this case is going to be, this should be a 2. 3 and 2 over a common denominator, and the common denominator is going to be 6. So I'm going to have to multiply the first set by 2, negative 22 over 6, plus multiply the second set by 3, negative 9 over 6 is equal to negative 31 over 6, which is in fact true. When I'm solving rational equations are equations containing at least one rational expression. So, I'm going to solve this the same way that I did the previous one. The only difference is I'm going to factor the denominator if possible, identify the non-permissible values in the denominator, determine the lowest common denominator, multiply it on each side to get rid of it, and then I'm going to solve it. So I'm going to do the same process I had. The only difference is I need to factor the denominator if possible and then state the restrictions. In the first case, I didn't have any variable in the denominator, so x could be any real number. When I take a look at this next example, I do have an x in the denominator, so there is going to be restrictions on the variable. So in this case, I can't divide anything out of the denominators. So I'm just going to say that x cannot equal 0. And I'm going to say that the lowest common denominator in this case is going to be 4x. That's what I'm going to multiply all the terms by. So I'm going to say that I have 4x and x over 4 minus 4x and 7 over x is equal to 4x times 3. Divide it out, and I'm going to, for the first one, divide the 4 out. So that's going to cancel out. In the second one, divide the x out. And in the last one, it didn't have a denominator. Which means that what I have is x times x, or x squared, minus 4 times 7, which is negative 28, is equal to 4x times 3, 12x. I can move that over because I have a quadratic. X squared minus 12x minus 28 is equal to 0. Then I'm going to factor this down and say that I have x minus 14 times x plus 2 is equal to 0. And theoretically, x can equal negative 2 or positive 14. Now I need to verify this. I got to double check that those actually work. So I'm going to state that in the first case, if I have negative 2 over 4 minus 7 over negative 2, does that equal 3? Well, negative 2 over 4 can get reduced to negative 1 over 2. And in the second one, the negatives can cancel out. So minus negative 7 over 2 can be the same as plus 7 over 2 is equal to 3. Negative 1 over 2 and positive 7 over 2 is going to give me 6 over 2, which does equal 3, and that one works. In the second case, I can say that 14 over 4 minus 7 over 14 is equal to 3. 14 over 4 can get reduced down to 7 over 2, and 7 over 14 can get reduced down to 1 over 2. 7 over 2 minus 1 over 2 is going to give me 6 over 2, which is still going to equal 3, and both of these cases work. Taking a look at example B. Now, unlike the previous ones, this one I do have to factor down in the denominator, so that's what I'm going to do first. I'm going to start by stating that 9 over, well, the y minus 3 can't get factored, minus 4 over y minus 6 can't get factored, is equal to 18 over, this last one can't get factored, and it's going to be y minus 3 times y minus 6. Then I'm going to state my non-permissible. Y cannot equal either positive 3 or positive 6. And I'm going to state my lowest common denominator is going to be y minus 3, y minus 6. I'm going to multiply both sides by the lowest common denominator. So I'm going to say that I have y minus 3, y minus 6 times 9 over y minus 3 minus y minus 3 y minus 6 times 4 over y minus 6 is equal to y minus 3, y minus 6 times 18 over y minus 3, y minus 6. In the first set, I can divide out the y minus 3. The second one, divide out y minus 6. And the last one, I'm going to divide out the y minus 3, y minus 6. Which means really what I have is 9y minus 6 minus 4y minus 3 is equal to 18. Or 9y minus 54 minus 4y plus 12 is equal to 18, which means that 5y is going to equal 60 when I move it over, or y is going to equal 12. I can substitute the y back into, or the 12 back into my y's, and the equation does balance out.